students. Today is Tuesday, May 5th, and I will be going over our lesson for today. As always, please watch the entire video. This video has a experiment that I do and it's pretty interesting, so I suggest you watch the entire video and listen carefully. Alright, so for Tuesday's lesson, it says you can earn an A on today's homework by watching the entire video and reading through every slide, so please do that. Our learning objective, I will apply my understanding of thermal energy transfer by conduction to decide on the best insulation for the windows of the house that will help to minimize, slow down the rate of thermal energy transfer. So we're going to do our house design discussion again, and for this time we're going to be deciding what should we cover the windows of our house with in order to slow down heat from entering our house. So before we get to today's lesson, just to quickly review what we learned on Friday. Friday we learned that darker colors absorb the electromagnetic waves that carry thermal energy from the radiation. So darker colors will increase, they will maximize the rate of thermal energy transfer by radiation. And we also learned that objects that are lighter in color, like white, they will reflect the electromagnetic waves so that they can minimize the rate of thermal energy transfer. So for your discussion for Friday, many of you got this correct, which was very impressive. It means you watched the video. So the question asked, what paint color would you use for the roof of your house if you want to slow down the rate of thermal energy transfer into your house? Many of you picked the correct one, which was white. You would use a white or lighter paint color for the roof, because you learned that lighter colors reflect electromagnetic waves and darker colored roofs would absorb the electromagnetic waves, and that would make the house heat up faster. So lighter colors would reflect the electromagnetic waves and make the house heat up slowly, so that would be the best choice. So good job on Friday's homework. Now moving on to today's lesson, this is video part 4. It'll be right over here if you need it. Again, this video goes over the answers that you need for today's homework, so please listen carefully and watch the entire video. I also say a password near the end. So this one is going to be about insulators, and we're doing an experiment. The experiment is keeping water cold. So the water bottle that I have here is cold, and the outside air around the water bottle is warmer. It's just like the house situation. Our house is cold and the outside air is warm in the summertime. So thermal energy will transfer from the outside air into the cold water bottle. Remember, it always goes from warm to cold. So since the water is cold, thermal energy will enter our cold water bottle, just like a house. Now the question that we're asking is, what material can we put around the water bottle? What material can we put around the water bottle in order to slow down, in order to minimize thermal energy from entering our water bottle? So I want my water bottle to stay cold. So what can I put around my water bottle to keep the water cold? That means I need to slow down thermal energy from entering my bottle. So in order to do that, we learned that we need to use insulators, because insulators do not allow thermal energy to move easily through it. Insulators, they prevent or they slow down the transfer of thermal energy. So if I want to slow down thermal energy from entering my water bottle, I can cover the water bottle with insulators. Now, here are 4 different materials that I used for the experiment. And I'm going to ask you, which material is the best insulator? Which material will keep the water the coldest? Remember, it has to slow down thermal energy transferring into the water. So which material will slow down thermal energy transfer? So again, we don't want a lot of thermal energy to enter our water. So if we cover it up with something like paper towel or plastic wrap or wool or aluminum, what will be best at slowing down thermal energy transfer into our water bottle? Okay, so I'm gonna go ahead and take the water bottles out of the refrigerator. I left it in here for more than 24 hours. And then now before we start the experiment, we have to measure the initial temperature of every water bottle. So remember, initial just means the beginning temperature of each water bottle. So they should all be around the same temperature since they've been in the refrigerator for the same amount of time. We're gonna stick our thermometer inside of each water bottle. Again, they should all be at the same starting temperature since they've been in the refrigerator for the same amount of time. Alright, so now we're gonna go ahead and measure the initial temperature of each one. So we'll zoom into our thermometer. Now this thermometer reads, it's around 41 degrees Fahrenheit. And then this one, this second water bottle, is also, as you can see, they're all at the same temperature. This one is also around 41 degrees. Just to prove our point, this one is also right around 41 degrees. This one as well, it's right around 41. And the last water bottle is also around 41 degrees. All right, so we got our initial temperature of each water bottle, and now we're gonna leave the water bottles out in this room for about 3 hours. And right now, the temperature of this room is definitely hotter than the temperature of our cold water bottles. So you can guess that thermal energy will transfer from the room to the colder water bottles since it always goes from warmer areas to cooler areas. So if I were to cover each water bottle with a different material, we're gonna see which material is best at keeping the water bottle cold. That means we're trying to find out which material is the best insulator that will slow down thermal energy from entering the water bottle. So this one is gonna be our control. I'm not gonna wrap it with anything. I'm just gonna put it in the paper bag and see how much thermal energy transfers into this bottle after 3 hours. Now for our next one, I'm gonna wrap this one in wool. Wool is a type of material that comes from the fur of animals like sheep. So this water bottle is wrapped up in wool, and the same thing, we're gonna keep it out in this room for 3 hours. And this one, I'm gonna wrap it in plastic. And then I have another one, and we're gonna wrap this one in aluminum foil. I know some parents wrap water bottles in aluminum, so we'll see what happens to this one. And then last one, we're gonna wrap this in a paper towel. All right, so we're gonna leave this out for 3 hours in this room. And again, thermal energy from this warmer room should all enter into the cold water bottles and make the water bottles gain thermal energy, which means that their temperature will go up. And we're trying to find out which material best keeps it cold. Now, before I show you 3 hours later, I want you to make your best prediction. Which water bottle do you think will stay the coldest out of these 5 bags? Alright, so you watched the video and we found out that the initial temperature of all the waters were the same, 41 degrees Fahrenheit. Now I left it for 3 hours and we're gonna watch the next video to measure the final temperature. Alright, so 3 hours have passed and now we're going to measure the final temperatures of each water bottle. So remember that thermal energy transferred from the room air to each bottle. So I'll open up each one and stick the thermometer and see what the final temperature of each bottle is. Alright, so the final temperature of the water bottle that was wrapped in paper towel is about 65. So the final temperature of the paper towel one is 65 degrees. And then the water bottle wrapped in aluminum foil is 64 degrees. And then the one wrapped in plastic wrap is about 61 degrees. And then the one wrapped in wool is around 54 degrees. So it's between 40 and 60, so 54 degrees. And the final, the one that was wrapped in nothing, it is at 71 degrees. So we're gonna look at the data on the next slide and we'll figure out which material was the best insulator, which one was best at keeping the water the coldest. All right, so here is our data from the experiment and we're gonna decide which one's the best insulator. Remember, if it was a good insulator, it would have kept the water cold since insulators slow down thermal energy from entering and leaving. So if you take a look at this, the best insulator was the wool because the wool kept the water at 54 degrees Fahrenheit, which is pretty cold compared to the original temperature. And then the second best was the plastic wrap. Notice how the temperature, if it's colder, it's a lower temperature. And then the third best insulator was the, oh, that one is an error, was the aluminum foil. And then it was the paper towel. So let me fix that really fast. And then the last one was the one with nothing around it. The one with nothing around it, if you can notice, it heated up all the way to 71 degrees because there was no insulator covering the water bottle. So the best insulator was the wool. It allowed the water to stay the coldest. Now you might be confused. You might say, how is that the case? Well, wool is material that's made from the fur of animals like sheep. And if you look at wool, what wool did is it slowed down thermal energy from entering the water bottle. It slowed down the hot air from entering the water bottle. Remember, the wool on its own does not have that much thermal energy. And you might be wondering, well, that makes no sense because when it's freezing cold outside and I put on a wool scarf, my body stays warm. Yes, the reason why that happens is because your body is warm and the outside is cold. So a wool scarf will slow down thermal energy from leaving your body. So that's why your body stays warm. So no matter what, wool is an insulator that slows down thermal energy from leaving your body, and wool slows down thermal energy from entering something cold. Okay, remember these two are different scenarios. In this one, the water is cold. In this one, the temperature outside is cold. So wool is an insulator that slows down thermal energy from entering and thermal energy from leaving. Now in a house, for your discussion today, in your house, it's kind of like the water bottle situation. The house is cold and you don't want thermal energy to enter your house. So if we put curtains on the windows, imagine the curtains are like the wool. The curtains will slow down thermal energy from entering our house. All right, so again, by putting up curtains on your windows, it's kind of just like this water bottle situation. By covering the windows, you're slowing down thermal energy from entering your house. Just like the water bottle, you're slowing down thermal energy from entering the water. So you're ready for your discussion. The discussion is going to be in this format, not our typing format. So hopefully you can all do well on this, but it does require a password. So the password for today's assignment is window, since we're talking about windows. So the password is WINDOW, window. So I want you to go to our class materials, and in the pink folder for week 7, click on house design discussion number 4. And then you will type in the password, which is window. So again, you're gonna type window and press start new attempt. It's only 2 questions long. As long as you watch the video, you should do just fine. All right, I hope that everyone gets 100% on this today. If you need help, please message me. Otherwise, I will talk to you in tomorrow's video. Have a good rest of your day.